You know those little everyday rituals you see? The ones that seem so simple you never really think about them? Well, today we're diving into one of those. We're stepping into the kitchen to solve a mystery that ties together ancient tradition and, believe it or not, modern physics. All of this right before breakfast.
So I want you to picture this. You're in Grandma's kitchen. You can smell that delicious, slightly sour scent of dosa batter just waiting, and there's a heavy iron pan on the stove, just slowly and steadily heating up. It's a scene that feels like home, right? It's played out for generations.
But here's where it gets interesting. Before she even thinks about pouring the batter, Grandma reaches for a little bowl of water. And with this quick, practiced flick of her wrist, she sprinkles a few drops onto that hot pan. You lean in to see what happens, and they just sizzle. Pfft, gone in a little puff of steam.
Grandma just smiles. She knows something you don't. Not yet, she'll say, kind of to herself. The pan isn't ready. And you realize, okay, this isn't just a random splash of water. It's some kind of test. But what exactly is she measuring? The mystery is on.
So she waits, maybe another minute, letting that pan get even hotter. Then she does the water sprinkle again, only this time something totally different happens. The real question is, what are we about to see that tells her it's time?
What we're actually watching here is this perfectly tuned little process. You could almost call it the water dance test. It's her way of finding the absolute perfect temperature. And what's so cool is that this kitchen tradition can be broken down into a super clear, step-by-step scientific method.
Let's actually walk through this little workflow. So, step 1, you got to heat that pan nice and slow. Step 2, you do the sprinkle. Step 3 is all about observation. Does it just fizzle and die? If it does, nope, not ready. What you're waiting for, the final, crucial step, is to see the water form these perfect little beads, these little spheres that just skitter and skate across the surface like tiny dancers on a hot stage.
And the second she sees that dance, she nods. Now. That's it. That's the signal she's been waiting for. The pan has hit its perfect state. And only then, not a second before, does she ladle on the batter and spread it out in that perfect, swift circle.
So, what is this kitchen magic? What's going on? Well, it turns out that this bit of generational wisdom, this simple little water test, is a perfect real-world demonstration of a really fascinating scientific principle. It's called the Leidenfrost effect.
Okay, here's the science behind the dance. When the pan gets hot enough, past a specific point, any water that hits it instantly creates this tiny, thin layer of steam right underneath the droplet. This vapor cushion literally acts like a hovercraft, lifting the water bead up so it's not actually touching the hot metal. That's what lets it glide around instead of boiling away instantly.
And this is just a brilliant example of how practical, hands-on knowledge often comes way before the scientific explanation. I mean, cooks have been using this exact technique to make perfect dosas for centuries. It wasn't until the 1700s that a German doctor finally described and put a name to it. So today, science finally gives us the words to explain what grandmothers have known all along.
All right, let's connect the dots here, because knowing about the Leidenfrost effect isn't just a cool party trick. It is the absolute secret to making a perfect dosa. Seriously, it is all about hitting that temperature sweet spot.
Think about it. If the pan is too cool, there's no vapor cushion, and that batter just sticks like glue. You get a clumpy, torn disaster. If the pan is way too hot, the effect is too strong. The batter basically floats on a cushion of steam and never really grips the surface, leading to these weird, burnt, holy things. But at that perfect temperature, the Leidenfrost point, the pan is just hot enough to stop sticking, but not so hot that the batter can't spread into that beautiful, thin, even circle.
And what do you get when you nail that perfect temperature? You get the dosa, the one that's amazingly crispy on the edges, but still soft and perfect in the middle. It's cooked evenly all the way through, and it just lifts off the pan, no fight at all. It's that delicious, reliable result you can only get through this precise, scientific little dance.
So really, what we're looking at is this incredible intersection of culture and physics. It's so much more than just a step in a recipe, right? It's a physical law being used perfectly to create something amazing to eat.
So the next time you're in a kitchen and you see someone flick water onto a hot pan, you're going to see it in a whole new light. You'll know you're not just watching someone cook. You're watching a scientist in an apron conducting a very precise, very delicious experiment.
And that's really the big takeaway here. Grandma's little Dosa dance test is so much more profound than it looks. As our source puts it so perfectly, it's not just a tradition, it's physics making your breakfast possible.
It really makes you wonder, doesn't it? If the secret to a perfect dosa comes from an 18th century German physicist, what other little bits of everyday magic are all around us, just waiting for us to see the science hiding in plain sight?